I'm going to go through the example applications and show you the different things we can do with the framework. In this first example, I'll go through in some detail, including walking through the framework as it's running. It'll be split into multiple videos, so they're not all just too long, and we'll just focus on one aspect of it. This first example is a very simple one: instrument identification. I can select an instrument attached to the PC and ask for its ID, and it will display in the indicator box here. So this is the front panel, and I've divided it into two parts because it's meant to be an example application that's reusable for future applications that I might create. And there are two parts. So I've got this example here with a panel on, but I've also set up a whole bunch of additional buttons here which aren't in use for this particular example, but might be of use in other examples. So I have a predefined behavior buttons, so pause and resume, we can do that with the framework. What I've dragged off this part of the front panel onto my panel here is the refresh and stop button. Refresh rebuilds this list of instruments here. It can automatically detect what's attached. Stop stops the processing. There are two of these controls here which are used to display the instruments that are attached, or at least the names of the instruments that are attached. There's two copies of those in case you want to select two different instruments in the example, and 10 action buttons. They're just called action buttons, but they're actually useful for actually driving behavior into the framework. Obviously they don't actually do anything, but they are programmed up to be detected, are pressed to be detected, and to raise a message to actually do something if you fill in the right part of the code. And this other aspect here, the IDs, is an indicator of IDs that are being generated for commands that are running through the framework. You may or may not need to use this, and you'll see how IDs are actually used when I get onto that part of the demonstration. So the instrument identification, if I run this, you see I've only got one instrument attached at the moment. It's the Raspberry Pi Pico. The name Pico PST has been defined in a program called NIMAX as an alias, and this is geared to display aliases. If you didn't have an alias, it would just display what is called the canonical name, which is a big string of characters, numbers. It doesn't really mean anything to a human, but it's the name that the LabVIEW will know internally. And when I press Get ID, it will send the message to the Pico to ask for its identity, comes back and displays it on the panel there. So that's basically very simple. It doesn't do a lot in this particular example, but it does flex through all the framework, and I'm going to give you a quick overview of the block diagram for this application. And I should warn you that it looks fairly complex, but that's because I've written it so that we can write more complex applications. I wouldn't normally use something like this to do a simple get identity. It would be it's way overkill for that. But as I say, it's there for more complex applications. And it's worth just pointing out quickly that you'll notice when I ran this, these buttons all disappear. I've got them set to hide so that you can't click them accidentally, although obviously if you don't put any code in for them, then nothing's going to happen. And the other aspect which you've just noticed here is that the application will time out if you don't do anything within 60 seconds. And that it times out so that it can reset the instruments to make sure that they're left in a stable state, for no other particular reason. And obviously you could change that if you want. I don't know if this video, the big grey block came on the screen. If it did, it's just part of Parallels. I'm running in a virtual machine here, and Parallels does that for some reason. Okay, so the block diagram. Let's make this slightly bigger. You can pause the video, read the commented text on here. So this is the front level VI of the application I have. As I say, it's an example application, and I've coded it up so that it's way more useful than just sending one command. But we can walk through this in future videos in detail and see exactly what's going on, but I just want to give you a quick overview of it right now so that it'll be quicker to get into it next time. And you can pause it and read the commented text on here. So the first thing that's going on is we're setting up the framework, and what I'm doing in there is creating values for my global variables. I need those for the events and the notification queues so that I can access them throughout the application. There are a lot of VIs that will be running and a lot of sub VIs within that, so the nested is relatively deep, and I don't want to be passing those through on the interface all the time. Those global values are set here and then only ever read after that. We've got 3 processing loops here. One is the event loop, and that is handling UI events and any events from the framework that I'm interested in. In particular, in this one, I'm interested in the stop event. When the framework raises a stop event, I want to know about it, the application wants to know about it, so I can close down properly. There's the main processing loop, and that is handling messages that I want to send into the framework, and the framework will send back to me. And there is a results handling loop. So when the framework is running and is generating results, it might be a long running process. You might be running this over, say, 10 minutes and gathering data, and you can post it back, and the results handling loop will be able to pick that up and display it on your UI whilst the application is actually running. So these 3 loops are running in parallel, so they're all running at the same time, all doing their own thing. Okay, so when we do stop, we register the event here, and that will raise a message onto the queue. And well, I mean, if I just very quickly show you, if we got this stop, it enqueues a message to tell the loop here to stop. That's picked up, and we turn off the LED, and we actually stop we run an exit state, and the exit actually tells the loop to stop. And this is a channel that routes that indicator, the true value, through to the parallel running loop here, the results handling loop here, and it's connected to the condition, so this loop will stop when the message is stopped. Now this event handling loop will stop of its own accord, you can see here, so that's already handled. And we then just unregister the events and destroy the global values that we've created. So it'd be worth just reading through these comment boxes to get a bit of an idea. I'll be going through each of these loops in a bit more detail and seeing how they're working in subsequent videos.